20 meters below the surface, off the coast of Florida, sits the Aquarius Reef Base. It is the world's only permanent underwater research laboratory, currently housing a team of researchers in a pressurized environment. While the United States already has a dedicated ocean research organization in NOAA, NASA has established its own ongoing presence here. These aquanauts live in the base for weeks, specifically to test operations like Project Nemo and the Orpheus submersible, an autonomous vehicle designed to dive 10 kilometers into the deep ocean. This mission treats Earth's deadliest waters as a high-stakes simulator, using the extreme conditions of our own ocean to prepare for contact with an alien world. Roughly 90% of all marine species inhabit the shallow sunlight zone for a very specific reason: physics. For every 10 meters you descend, the water pressure increases by an entire atmosphere. At a depth of 3.5 kilometers, the pressure is so immense that any structural failure leads to an instantaneous implosion. The destruction occurs in a millisecond, faster than the human brain can process pain. NASA is currently designing machines to operate 3 times deeper than the wreckage of the Titan. Surviving these crushing physical forces is a mandatory engineering prerequisite for the actual mission they are planning in deep space. Most of our biological assumptions rely on the presence of the sun. In reality, biology requires only 3 components: liquid water, specific chemical elements like carbon and sulfur, and an energy source to drive their interactions. In the Hadal Zone, the ocean's deepest reaches, hydrothermal vents act as underwater volcanoes. They blast mineral-rich water heated to 400 degrees Celsius into the pitch-black environment. Energy rising from the Earth's core, rather than the sun, powered the formation of the first complex biomolecules. This realization provides a specific environmental profile for where life can exist in the universe. Searching for these specific criteria within our solar system narrows the focus quickly. Venus is far too acidic, and the surface of Mars remains a dry desert. Jupiter's 4th largest moon, Europa, presents a different scenario. Jupiter's immense gravity stretches and squeezes the moon, generating massive geothermal heat within its core. This maintains a global saltwater ocean beneath the ice, containing twice the volume of all liquid water on Earth. Because Europa shares the same chemical and geothermal conditions as Earth's deep sea, it represents our highest statistical chance of discovering an alien ecosystem. The first phase of this effort is the Europa Clipper satellite, scheduled for launch in late 2024. Europa is 1,600 times further than our moon. Reaching it requires looping around Mars and Earth to build momentum. Upon arrival in 2031, the probe performs overlapping loops around Jupiter's moons to map ice thickness and atmospheric composition. Phase 2 involves a nuclear-powered cryobot designed to land and spend years melting vertically downward through up to 20 kilometers of solid ice. Once it reaches the ocean, the cryobot will release 48 micro-swimming robots into the darkness to search for signatures of active biology. This search for an alien ocean requires a level of engineering precision and a multi-decade timeline that exceeds any mission humanity has ever attempted. Despite having telescopes capable of looking millions of light years away, we have yet to find any definitive proof of life beyond our planet. Our specific interest in Europa is based on data collected by probes launched decades ago. Our search also contains a built-in limitation. We are exclusively hunting for water-based biology that mirrors our own. It is possible that life in the universe operates on chemical foundations that we don't yet recognize. While Europa is the most logical target based on our current understanding, we are still relying on a single biological model to guide our search. Regardless of the low probability, scientists across the globe are setting aside national borders and political differences to pursue this search. Even if the mission finds no life, the extreme technology developed to reach Europa directly advances human capability in medicine, communications, and deep-sea exploration. Pure curiosity and the courage to execute these missions are what drive our evolution, providing meaning to our civilization, regardless of what we find in the oceans of Europa.